Hey everyone. So I know that balancing equations can be a little bit tough sometimes, so we're just going to go through a couple of equations together, starting with some easy ones and then getting a little bit harder just to give you some extra practice. All right, so the first one we're going to look at is if we have gallium and we're going to react that with some chlorine gas. And we would never want to actually do that in real life because chlorine gas is super dangerous. It's super poisonous, and it's something that they used in World War II. You might have heard of it as mustard gas. There's your friendly fact of the day. Okay, so we're going to start off with this one, and a couple of things to do just to make sure that you're more likely to be successful when you're balancing things. First off, I would say draw a line in between the arrow. You don't have to do this as you become much more comfortable and much more confident and competent in balancing, but this is just going to help you remember that what you're going to be talking about on this side are your reactants, and we're going to be talking about this side are your products. So we're just going to keep the elements that we're talking about on each side separately. Second thing that we're going to do is we're going to write down the elements that we have on each side, and it makes it a lot easier if we write them in the same order on each side. So even though you'll see in later examples the gallium isn't necessarily going to be the first element, we want that to be at the top because it makes it a lot more easy for us to compare across to see how many we have. All right, and here, so we're going to start off gallium. We've got 1 because there's that invisible 1 that we never write. And chlorine, we can see from this little number that we've got 2 on that side. Gallium on this side, again, we only have 1. And this time we have 3 for chlorine. So this one's not as obvious as if we just have 1 and we have to multiply it by the number, because over here we have 2, over here we have 3. So the simplest way of thinking about this is what's the lowest number that both 2 and 3 will go into, so that lowest common denominator. And the easiest way for us to do this is actually just multiply them by each other. So if I multiply this by 2, this is going to give me 6. But anytime I am putting a number down here, I have to make sure that I go back up to the equation and I represent that here. So here I'm going to be putting a 2 that goes in front of the entire compound, this whole thing, gallium chloride. And since that 2 is also going to be now impacting gallium, I have to write that down as times 2 as well. So if I look over on this side, I can see that I've thrown off my gallium here. And that's going to have to be balanced again. So I can do that if this one's 2 and this one's 1. I'm going to multiply that by 2, and that'll give me a 2. And I'm going to represent that by putting the number that I multiply it by up here. And then for chlorine, this one is already 2, and I want it to equal 6. So I'm going to multiply this by 3. Anytime you finish a formula, always just take a look at your equation and do that nice little quick check to make sure that you've got everything sorted out properly. So here I've got 2 gallium, 2 times that invisible 1. Here I've got 3 times 6 chlorines, so 3 times 2. Here I've got 2 times 3 chlorines, so again, 6 chlorines. And here I've got 2 times gallium, so that invisible 1, so I've got 2 galliums as well. So this one is all balanced out. Let's look at something that's a little bit tougher. So we're going to add in a few more of our different elements here. So we'll start off with calcium hydroxide. And we're going to add some sulfuric acid. So long compound, short name. And that's going to produce calcium sulfate and H2O. So already we can see that we've got a couple of things that look similar on each side. So here we've got our sulfate, and if it helps you at all, you can put brackets around the entire polyatomic and do this with all polyatomics. You can put a little box around it. Whatever it helps you to remember that when we're talking about this polyatomic, we're talking about SO4, not SO. So a lot of times students will make the mistake, as we'll do in a second, and they'll write down, well, let me show you. Let's not get too far ahead of ourselves. So we're going to do the same steps that we did previously. Here we're going to write down our different elements. So we've got calcium. I'm going to keep this OH together, and I'm going to show you why that makes it easy in a second. I'm going to put down my hydrogen from over here, and then here Again, I'm going to keep my polyatomics together. Now this OH, I'm only going to keep that together if I either have a hydroxide on this side or if I have water here. So water, we can actually rewrite that in a way that makes it a lot easier if we have a hydroxide on the other side. So I'm going to actually write water like this, like a hydrogen and a hydroxide. Notice that there's still just two hydrogens that we're looking at in that compound. But here we've got that OH and we've got that OH coming up over here. So we want to try and make this as easy as possible. If we had H2O, then we'd be trying to balance the H on this one piece with both the hydrogen here and the hydrogen over here. Separating that out into an H and then an OH in brackets means that this OH is just balanced with this OH and this hydrogen is balanced with hydrogen. So if you can kind of group them together so that you don't have to separate out the same element in different compounds, that just makes it much easier. So you'll notice here that we put down SO4. Make sure you don't make the mistake that is a really easy one to do, where instead you just write down SO and then you say there's 4 of them. That's not true. We have 4 oxygens, not 4 sulfurs. So again, if that box or the brackets help, do that. So calcium here, I've got 1, the invisible one there. I've got 2 hydroxides, so 2 of this whole thing. I have 2 hydrogens, and I only have 1 sulfate, because nothing else is on the outside here. For calcium, I've got 1 calcium, I've got 1 hydroxide, 1 hydrogen over there, and 1 sulfate. So this is actually going to be pretty straightforward. My calciums are already balanced, my sulfates are already balanced, so I just need to go through and actually balance on this side. So if I see that 2 there, I'm going to be multiplying this by 2 to give me 2. It doesn't really matter which way you start, although it's always good to leave hydrogen and oxygen until the end. As we're going through, so we've got that 2 there, so we've got 2 hydrogens, but since we multiplied by 2, we've got to show that somewhere. I'm going to show that by putting the 2 in front, so that 2 multiplies this hydrogen. That also means that that 2 is going to multiply the hydroxide, so that it ends up being 2 as well. And I do a quick look, and I can see we've got 1 calcium on each side. We've got 2 hydroxides on each side. We've got 2 hydrogens on each side. And then I've got 1 sulfate on each side as well. So this one is also balanced. So taking a look at the next little thing that we can do is a little bit of a tougher situation. So here we're going to have copper, an oxygen for copper oxide, and aluminum and phosphate. And I just tried to create something that gives you a little bit more practice. So you have to do a little bit more back and forth trying to figure out how to balance it. Okay, and then do our lines. Again, you'll get comfortable with this enough that you won't have to do these like cutting it in half and then writing everything down. So, but you need to learn the steps first so that you can kind of make it more mental. You kind of own the steps a little bit more. So this side we have 1 copper, we've got 1 oxygen, 1 aluminum, 1 phosphate. Again, phosphate being that whole chunk there, PO4. Here we've got 3 coppers, 3 oxygens, we've got 2 aluminums, and 2 phosphates. So all of these are different numbers. But hopefully you can already see that here we've got 3 of these, we've got 1 of these. So if I multiply my copper by 3, I'm going to end up with 3. I'm going to put that 3 in front here to show that this will be multiplied by multiplying copper. But I also have to do the same for the oxygen. So here we've got that times 3, so that gives us the 3 as well. So we've actually got those 2 balanced out already. And here, this one needs to be multiplied by 2. So multiplying by 2 will give me 2. I'm going to have to put the 2 up there, so this 2 will multiply my aluminum. That's where this comes from. But I also am going to be multiplying the phosphate as well by 2. And then I can wonderfully see that everything has ended up lining up. So sometimes you just need to go back and forth a little bit, and then eventually you'll just have the numbers check out always check at the end to make sure that this equation matches, the reactants match the same number of each atom of each element on the other side. So here we've got 3 coppers, 3 coppers. Here we've got 3 oxygens, 3 oxygens. 2 aluminums, 2 aluminums, and then 2 phosphates, 2 phosphates. Okay, our very last one. So this style tends to be a little bit more confusing, perhaps, than some of the other things that we've done. So we're going to look at something that is going through combustion, so it's burning. And so we've got 7 carbons, 10 hydrogens. We've got our oxygen there. And again, oxygen has to be found as part of a pair because it's one of those diatomics, or as we talk about, Hoffenbrinkel. All of these are always found in pairs. Okay, so let's just go back to our balancing. We're going to write down how much we have of each one, just like we have every time before. Because I have oxygen in these 2 different ones, I'm going to actually write them down separately. So here I've got 1 carbon, got 2 hydrogens, and for my oxygen, this first compound only has 1 oxygen, so I'm going to put a 1 over there. I'm going to put that plus sign in there as well. And this compound has 2 oxygens, so I'll put a 2 there. I just do this because if I'm changing the number in front here, that should only be changing this oxygen. And if I'm changing the number in front here, that should only be changing this oxygen. So it's just a nice way of being able to separate something out when you have the same element in 2 different compounds. Okay, so as we said, always leave oxygen to the end. Anything that you have solo, where there's no other elements with it, leave that to the end because those are much easier to balance. So with carbon here, we've got to multiply that by 7. That's going to give us 7. And I have to put that 7 in front so that these numbers match up. For hydrogen, I would need to multiply that by 5 to be able to get 10, like we have on the other side. And so I put our 5 in front there. And so we've got to go back. When we put that 7 in front for carbon, I changed this number, but I did not change the number for oxygen. So this should also be times 7, which gives me 14. Here, I have that 5 in front for hydrogen, so that's 5 times 2 to give me 10. But I also now have this times 5 for oxygen. So now what I have is something that is 5 plus 14 oxygens, which is going to say I need 19 oxygens. So here, my carbons are balanced, my hydrogens are balanced, my oxygens look kind of ugly right now. So I want you to think about it this way. There is some number that I need to put here, and I'm going to represent that with an x. And I need to have x times 2, because we have 2 oxygens here, equal to 19. I'm just going to scribble that out so we have some space here. Anytime I have something that I'm trying to move over, the easiest way for me to do that is to do the opposite operation, and that helps move it over to the other side. So here this 2 is multiplying the x, so I can just actually divide it by 2, because division is the opposite of multiplication. Whatever I do to one side, I have to do to the other side as well. So that would mean that I have to divide this by 2. Rather than actually leaving it in some kind of decimal form, I can just leave this as a fraction here. So the number that I need to put in front of my oxygen here, the oxygen that has 2 atoms, is going to be 19 over 2. Okay, that one's a tough one. You're only going to see a couple of those pop up, but hopefully that gave you an idea of how to go through it. All you're doing is trying to figure out what is it that you have to multiply this by 2 in order to get this number. So generally, if it's an uneven number, it's always going to be that number divided by 2. Hopefully that helps. If you have any more questions, you can let me know, and we'll talk more about this in class.